Dear students, in this session, we are going to learn about supervised perceptron model. So we have seen what is perceptron, MCQ Lockpick's perceptron model. In the MCQ Lockpick's perceptron model, it will take only 1 or 0 as the input values. But here it is different. So it can take the values from 0 to 1. And we are telling about the supervised. Okay. So it is a supervised perceptron model. And this was introduced by Frank Rosenblatt in 1957. He designed a perceptron rule-based neurons, and it is an algorithm for supervised learning with the help of the binary classifiers. And this algorithm enables to learn and process elements in the training set. Okay, so first we will train the data, then we'll go for the testing the data. In the training the data, this particular model can be used for classification problems. So if you see the diagram, same thing. You'll have all the weights, inputs, and these are all the weights, and this is the bias. And I'm calculating the threshold net input function, and I'm getting the activation function, and this activation function will be related to the classification problems. So it will tell that if the threshold value is 1, it will belongs to one class. Otherwise, the threshold value is 0, it will belongs to another class. So what are the basic components of this particular perceptron, supervised perceptron model? First, we'll have the input layer, or how we have seen here. Already we have seen here. One second. So this is our input layer. If you see 1, x1, x2, xm are the input layers. Second one is weights. Each input will be associated with weight. If you see here, x1 is associated with w1, x2 is associated with x2, sorry, w2, xm is associated with w3. Then bias. Okay, here one is the bias. So we have seen why we use the bias. In order to increase the strength of your particular neuron, we'll go for the bias. Next, activation function. So again, I'm going for the back. So this is our activation functions. After calculating the summation value, I have to use the activation function. Here I'm using, we can use any function, step functions, sigmoid or ReLU functions, which can be used in your perceptron models. And finally, I have the output. The output will have either 0 or 1 or a single binary value or any category values. Okay, so this is related to the part of your components of the perceptron model, which is supervised one. Next, we'll have the training algorithm. Okay, so first we have to train the network. Then we can go for the test that particular network. Suppose if I have a data set which is related to dog or a cat, so I'll use the training. First, I'll set that particular train with that particular data set using a perceptron learning algorithm or backpropagation algorithm using your Keras, TensorFlow, PyTorch or anything. Then we have to adjust the weight in order to minimize the error while training itself. Finally, you can test this particular algorithm whether the image is a dog or a not a dog after performing the test. So this particular training algorithm will be used for train the complete data set. Now, so what is the perceptron model we are using in the machine learning? As I said, we can use for the classification problem. So it will also used for detecting the certain input and computation for the business intelligence. And this is one of the best and most important model in ANN. And it will have the 4 main parameter values like input bias and EDSM and activation function. So we will use this particular algorithm learning purpose because it is a supervised model. How does perceptron work? So exactly how this particular perceptron is working. So already we discussed what are the 4 parameters: input, weight, and bias, and you'll get the net sum and activation function. So what we'll do, we'll use only single layer, and this perceptron begins with the multiplying with all the input values with the weights. Yes, so W1 into X1 plus W2 into X2 plus so on, Wn into Xn, and these are all creating weighted sum. And then we are applying to the activation function F, and this will decide activation function to represented F, and it will give the output according to the threshold value. Okay, so this activation function will act as a threshold for deciding the output. Yes, exactly. Same thing, X1, X2, Xm. I'm calculating the net input function, activation function, and I'll get the output. If any error is there, again, I'm going to send back to this particular weight adjustment because we are using back propagation algorithm. So we will back propagate the error into the weight. So we'll modify the weight here. So in this example, step 1, first we will multiply all the weights. So these are the weights. So here it is x1 is the first input and w1 is associated this particular x1, x2 w2, x3 w3, so on x4 w4. So this is our sum, weighted sum. Then what we have to do? I have to go for the threshold function. So what is our activation or threshold function? Step 2. So an activation function is applied, mentioned by summing up this one particular. So y equal to f of summation weights, what I have calculated, this one, plus b, what is the bias. So this will give the our summated output. Then what we are going to check? Then we have to check the condition with your threshold value. If it is within the threshold, we will go. Otherwise, we will change the weight. So this is a basic thing of how the perception. After getting the activation, after getting the net input, I'll check with the activation function. If it is okay, I'll go with the output. Otherwise, I'll throw back the error to the weight and weight will be updated. And this loop will be continued unless until activation function is satisfied. So this is regarding perceptron working model. Now, what are the types of perceptron models? So already we have discussed. So this is single layer perceptron where you will have only one layer. Second one is multi-layer. You will have multiple layers, one input layer, more hidden layers, and one output layer. Forward stage only you can forward. That is, you have the input layer on the stage, and you can only terminate on the output layer, not go back to the input layer. And you cannot feed forward. We cannot feed backward. Only it will move in the forward stage. Second one is backward stage. We can move back. Okay. For example, we have seen here. So I'm backing this particular error. So this is backward stage. Forward means I cannot do this. I will add one more layer over here and I can do the same thing. So this is your backward stage. And what are the basic advantages of this model? So a multi-layered perceptron model can solve the complex problems. So if you have very complex problems, we can use multi-layer perceptron model. It will work for both small and large data. It helps in the quick predictions and it helps us to get the accuracy ratio, same accuracy ratio with small and big data. So this is related to supervised perceptron model, which will have types of models. So just remember 4 parts. One is input, one is weight, one is bias, and activation functions. Finally, we'll get the output.